So welcome to week number 4 and week number 5. So we have processing data, and after this one is we have data analysis. So today we will be discussing about processing data. So what is data processing and why it is necessary? Data processing is a series of steps undertaking to put the collected data into a form that is suitable for statistical analysis. Data processing facilitates analysis. During the process, the completeness, consistency, and accuracy of the data are checked. The process generates statistical outputs such as descriptive statistics, cross-tabulations, regression, and etc., which also the researcher can readily analyze. The collected data must be checked for completeness, consistency, and accuracy and converted into a form that will facilitate analysis. So that is processing data as well as data analysis later.
Let's proceed on data. So what do you mean by data? So in statistics, it always deals with data. So data can be classified according to its type, category, and level. So knowing the type and category and level is important because knowing the nature of data determines what types of statistical analysis can be used with it. So as we recall, data are the collection of facts or information such as words, numbers, measurements, and etc. So data are the basic inputs in any decision-making process. So what are its types? So there are two types of data, or the basic types of data: qualitative data and the quantitative data. So when we talk about qualitative data, these are data uses words, and quantitative data, these are data uses numbers. So in research also, there are two categories. So we have qualitative research and versus quantitative research. So in the qualitative research, so this is a method of inquiry employed in many different academic disciplines, traditionally in the social sciences, but also in market research or further context. Whereas in the quantitative research, this refers to the systematic empirical investigation of social phenomena via statistical, mathematical, or numerical data or computational techniques. So in summary, if we describe qualitative research versus quantitative research, so in the qualitative research, the main data here is through description, whereas in the quantitative, the main data is uses numbers. So in qualitative research tools, we'll be using observation, interview, focus group discussions, documentary analysis. Whereas in the quantitative, the research tools you'll be using are test, checklist, questionnaire, and survey. Another thing is population or study population. You'll be using in the use of qualitative research. It's based on the design, no required number. Whereas in the quantitative, the population are used usually uses sampling techniques. The more respondents, the better. Another category is in the qualitative uses the actual responses of the subjects in the interpretation, and it's taken individually. Whereas in the quantitative research, this uses the quantitative representation of the subjects in the interpretation, taken as one. So for the treatment of data, for the qualitative primary versus secondary data. So again, there are two types of data collection methods. You have the primary data and the secondary data. In the primary data, this is also known as your raw data. It means original data. It is obtained from studies, observations, interviews, researchers, and experiments conducted by you as a researcher, you personally for a specific purpose. Whereas in the secondary data, this is a type of data that has been collected by someone else for a purpose different from yours. What are the two types or two sources of secondary data? Number one, we have the paper-based sources. Those books, journals, periodicals, abstract, indexes, directories, research reports, conference papers, market reports, annual reports, internal records of organizations, newspapers, magazines. These are your paper-based sources under the secondary data. Another source of secondary data is by the electronic sources. Those from CD-ROM, online databases, internet videos, and broadcasts. These are the secondary sources of data. Alright, what's the difference between the quantitative data versus the qualitative data? In the qualitative data, so there's no basic, or there is a basic or number or label only. So this is a non-numerical attributes. Categorical. So what are the examples? You have color, model, brand, type of defect, etc. Whereas in the quantitative, these are numerical scale, numbers. These are data used as numbers. Examples, this can be measured, no? Because there is numbers. Examples, counts, time, temperature, mass, weight, length, and etc. Alright. So you will have a post-its after this. Okay, now let's discuss about the types of data. So we are done to define what is data. So we all know that data can be defined as a systematic record of a particular quantity. It is also a collection of information and figures to be used for a specific purpose, such as survey or analysis. And there are two types to recall. We have qualitative data and quantitative. The qualitative, they represent some characteristics or attributes. They depict descriptions that may be observed but cannot be computed or calculated. So again, qualitative data is data uses words. Quantitative data, this can be measured and not simply observed. They can be numerically represented and calculated and can be performed on them. So this can be numerically computed. So again, quantitative data, this data uses numbers. So types of data, we have the primary and the secondary data. The primary data, these are also known as your original data. So in the original data we're in, these are the data that are collected for the first time by an investigator for a specific purpose. So in the primary data, these are pure in the sense that no statistical operations have been performed on them and they are original. Whereas in the secondary data, these are the data that are sourced or these are sourced from some place that has originally collected on it. So this means that this kind of data has already been collected by some researchers or investigators in the past, or is available either via published or unpublished form of research. So this information is pure as statistical operations. They have been performed on them already. So we will define what are these types of data according to cross-sectional time series and pooled data. So when we talk about time series data, it is a collection of observations or behavior for a single subject or a single entity at different time intervals, or meaning generally equally spaced. So like for example, we wanted to identify the maximum temperature, humidity, and wind in all three behaviors in Cebu City. Specifically Cebu City, it's a single entity or place collected on first day of every year, meaning multiple intervals of time. What does it mean? So we will take note on every year, meaning yearly. So we will identify the maximum temperature, humidity, and wind. So how to go about it? So you have the name of the city and the date. So specifically, we will give an example. Today is September 27. So every year, September 27, 2020, September 27, 2021, 2022, and so forth. So we will check on the different or the three behaviors. Now we will observe the three behaviors according to its maximum temperature, humidity, and wind in specific city. That's in Cebu City. In every year, meaning there is multiple intervals of time. That is what we know as time series data. In cross-sectional data, it is a collection of observations or behavior for multiple subjects or entities at a single point in time. So what's the difference here is that you have the three behaviors. So I give you an example. So we will use that one as an example: maximum temperature, humidity, and wind, both in three behaviors, specifically in Cebu City, or in Mandawi City, or in Lapu-Lapu City, or even in Talisay City. So these are multiple entities in a specific or single instance or on point of time. So just like for example, today only, we will compare or we will identify or collect observations according to maximum temperature, humidity, and wind of specific cities like Cebu City, Mandawi, Lapu-Lapu, and Talisay City. So for today only. So we will record the name of the city, the date is today, September 27, 2020, and what is the maximum temperature, humidity, and wind. So we record. This is how you are going to record on based on the types of data under the cross-sectional data. So for the pool data, so when we talk about pool data or pooling, this can refer to a combining data, but it can also refer to combining information rather than the raw data. So in this sense that what's the difference between pool data and panel data? So as we recall, to differentiate between these two, usually the pool data is more on is a combining of the cross-sectional data we are in. So in this sense that the time series and cross-sectional, they come into a variety of forms, and the most common used here is the panel data. So here in the panel data, or also known as the longitudinal data, it is usually called as cross-sectional time series data, meaning it's a combine of the time series and the cross-sectional series, that is a combination of above-mentioned type. So like for example, a collection of observation for multiple subjects at multiple instances. So for example, we will still use the example of maximum temperature, humidity, and wind in all three behaviors again. Here in Cebu City, Mandawi City, Lapu-Lapu City, and Talisay City as multiple entities on first day of every year. That's multiple intervals of time. So wherein you have the city, the name of the city, and the date. It's by yearly. So we'll take note this combination of time series data, the first example that we had, and we will determine the maximum temperature, humidity, and wind. So specific, but it's a multiple entities in multiple intervals of time. You will measure on the three behaviors or observations that you need to collect on specific data. That's how we know as the panel data or longitudinal data, or also is your pooling of data. Variable. What are variables? Why should they be specified? Identification and specification of variables are essential in the setting. So variables are events, factors, or characteristics which vary from person to person, or the same person at different times. In research, variables may be the characteristics of the subjects, the outcome of results of a process, or factors that have some influence on the subject of inquiry. They are therefore tools and bases for classification of subjects and the indicators used to measure the event or changes in the event under investigation. Hence, the object of observation or measurement and should be identified and specified early in the planning of the research. So there are several indicators required to measure the event or the changes. So variables are either qualitative or quantitative. So when we talk about qualitative variable, this is one that is not expressed numerically. So example, sex, and civil status, and others. So in this sense, that the qualitative variable, these are variables for which data does not come from measuring or counting. So data concerned with descriptions, which can be observed but cannot be computed. So example, gender, the eyes, color. So this represents your qualitative variable. In quantitative variable, it's one that is expressed numerically. Example, age, height, and weight. So in this quantitative variable for which data come from measuring or counting. So example, we have the marks or results of exams, and grades of exam, the way, number of accidents. So this represents your quantitative variable. So a quantitative variable also may either be discrete or continuous. Discrete variable, this means that you can assume only integral values or whole numbers. Example, number of children. So when we talk about discrete, these are data can take only certain specific values rather than range of values. So the usual way to represent this is by using your bar charts. So the discrete data or discrete variable, these are finite. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, stop. Or countably infinite. 1, 2, 3, 4, 5, and so on. And can list the values. One of first natural numbers of finite. One of every natural number of countably infinite. So data can be count numbers of people with certain blood type, number of events, type of faces, dies, and others. These are examples of your discrete variable or discrete data. Whereas in the continuous variable or continuous data, this can assume both the whole numbers and fractions. Examples are height and weight. So in the continuous data, these are data that can take values between a certain range, the highest or lowest values. The difference between the highest and lowest value is called the range of data. And the usual way to represent this are using your histograms, it's like also your frequency distribution. So in the continuous data or variable, these are uncountably infinite, and 0 and 10 possible decimal number. It includes an interval of real numbers. Although we often round it off the continuous data, if measured more precisely, then we can obtain more decimal places. So if examples, n are heights. Just like for example, you have 5 feet 4 inches tall. Then you have also weight. It's 110 pounds, 50 kilograms, 50.1 decimal. Length in centimeters, measure, let's say 55 centimeters. It's the length. Speed, like for example, speed is kilowatt per hour. How much? Specify a specific speed. That's 10 kilometers per hour. So there's a measurement. And temperature, like 36.3 degrees Celsius, 101 degrees Fahrenheit, etc. These are example of their continuous variable or continuous data. Now, there are two kinds of definitions are required in defining variables. So we have the conceptual definition and operational definition. So we talk about conceptual definition. This is to define the variable as it's conceived. For example, obesity is defined as excessive fatness, overweight, etc. This is according to by concept. You get this one from the information directly from the books. Could be, and it is the exact definition based on the variables that we wanted to define what is obesity all about. When we talk about operational definition, this is working definition. This defines the characteristics to measure. It should be objective, observable, sufficiently clear and explicit to avoid ambiguity. So this is to ensure similar findings can be obtained if the study were performed by different investigator or repeated by the same investigator. So example, you have repeatability and reliability. For example, obesity is defined as a weight based on weighing using a bathroom scale in underclothes and without shoes, which exceeds the upper normal limit of BMI or body mass index of the subject's sex, age, and height. That is operational definition. Now, in the conduct of we defined about metric and non-parametric. So, in statistical methods were developed on the basis of the number of assumptions about the nature of the population from which the study results are drawn. Now, we talk about parameters. So, we have metric and non-metric. So, we will identify which one is metric and non-metric. So, in parameters, these are population values, which assume that the values obtained are based on the normal distribution in the population of interest. Non-parametric statistics also used as to determine the distribution also of the population. So non-metric data, this refers to all of the structured data. So we talk about information that is ranked. This is what we call as ordinal. According to the scales of measurement, there are 4 levels of scales of measurement. So we have nominal, ordinal, we have interval, and ratio. So in this sense, in non-metric data, ordinal, these are information that is ranked. This is what we know as ordinal scale of measurement. But information that has no linear pattern to it is called as nominal or categorical. So in this sense, the scale of measurement, this refers to the type of variable. So there are 2 types. We have the categorical or discrete. This belongs to nominal and ordinal. And we have also numerical, that is continuous and metric. So how to specify the scale of measurement to be used? The selection for a scale is determined by the variable itself and the methods available for measuring it. So categorical variable, the first variable here is nominal variable. This consists of 2 or more mutually exclusive categories presented as counts. A type of data in which the variables are divided into a number of named categories from the word nominal comes from the root word name. These are categories, categorical, according to names, not name. These categories, however, cannot be ordered or graded one above another. So examples are race. No? Race. When you talk about race, so we specify the name like Malays, Chinese, Indians, Filipinos. We have also Nigerians, Nepalese. We specify the race. So what about sex? No? There are two only. We have male and female. That is according to nominal variable. What about ordinal variable? These are a type of variable in which the responses are divided into a number of categories. It can be ordered one above another. The categories can be ranked. So example, we have level of knowledge, poor. So we talk about level of knowledge. So we determine the scale of measurement here is poor, average, good. Another variable is opinion of individuals. So in the scale of measurement under ordinal, you will indicate there fully agree, disagree, and totally disagree. This is how you're going to check on examples for framework for defining variables according to the scale of measurement. In the numerical variable, this consists of continuum of measurements, a type of variable in which there is an unlimited number of equally spaced categories. Thus, a continuum of values is possible. It consists of actual measurements of individuals. So like for example, age. So 1 year, 35 years, 70 years. Hemoglobin level like 12.1, 13.6, like 7.2. Birth weight like 3.71 kilogram, 2.75 kilogram, 4.01 or 01 kilogram. So these are example of numerical variables. So there is specific values or continuum of values, meaning unlimited number of equally spaced categories. So we will try to identify, like for example, I give you an example, a variable, and you need to define first before you will indicate the scale of measurement. So if the variable, if it talks about your variable is all about age, you define first how you interpret, how in your research make use of this age, how you define the variable. So we talk about age, like for example, the child's age at admission to hospital, calculated from date of birth and date of admission. In that way, you can identify or you can check what scale of measurement you're going to indicate. So meaning to say, from the variable age, you will put the scale of measurement here by according to months and years. So you put here category in months and years. And then another example is patient has dengue fever. That's the variable. You define first how you interpret that data or the variable. So dengue fever confirmed by serology, IgM positive or 4-fold rise in IgM titer, or your virology. That is one way to check, to determine that the variable has a dengue fever. So in your scale of measurement, you will indicate either yes or no or not applicable. Another example, social class. So how you define the head of household's main occupation as stated by respondent in answer to a question in a structured questionnaire. So in the scale of measurement, you will indicate there detailed occupation and classified into social class 1 to 4. Another variable is hemoglobin. So hemoglobin concentration in capillary blood measured by hemoglobinometer. So your scale of measurement here is according to gram per deciliter. Another variable, patient satisfaction on counter services at clinic. So you define first, these are response to specific questions put to patients on counter services at clinic. So response to a question during a structured interview. In the scale of measurement, you will indicate here like patient satisfaction. So is it very satisfied? Patient satisfaction, is it satisfied? Don't know or no answer. Somewhat dissatisfied, and then very dissatisfied. That's how you're going to indicate your level of or scale of measurement. Another variable, level of education of mother. So highest education level achieved by mother as obtained in answer to a question in a structured questionnaire. So father may be interviewed if mother is not present. So in the scale of measurement, you will indicate the level of education of mother. Is it no education? Next is primary school, secondary school, college, or university. So this is one way so that they can check whatever it may applies to them. And last example is severity of illness at birth. So you define first. This is a requirement for resuscitation at birth as recorded in referral letter or medical records. So in your scale of measurement, you will put it here like the severity of illnesses at birth. So cardiopulmonary resuscitation or CPR, IPPV with intubation, PPV with bag and mask, nasal oxygen or NIL or NIL. So that is one way to be able to identify and according to the level of the scale of measurement, so that you will be able to identify what type of variable it is, and then what categories or what type of variable that you're going to identify. Is it categorical or numerical? So another thing is that to identify in the conduct of research, it is essential to identify which variables are. So what are the different types or the types of variables? There are three types of variables. So we have the independent variable, dependent, and the confounding. So when we talk about independent variable, these are the factor that affects the value of dependent condition that produces the outcome. In a cause and effect relationship, it is the cause. In an experiment, it is what the researcher manipulates or varies. How does who is or what is the cause? That is the independent variable. In the dependent variable is the factor whose value is affected by the independent variable. It is the outcome of a process. It is the effect in a cause and effect relationship. It is the indicator of change in the event. And lastly is the confounding variable. It is a variable which is not the principal interest in the study, but it distorts the results of the study because it is associated with both the independent and dependent variables. If age and or sex are not factors under investigation, they usually confounding variables because they are usually associated with independent and dependent variables in studies of relationship. So for example, in a study of smoking and coronary artery disease, unless the sex composition is controlled, so more females would find their way in the non-smoking group. As a consequence, the coronary artery disease rate in this group would be lower than the smoking group. Whether or not smoking influences coronary artery disease occurrence, since females are protected by estrogen. So the variable must be defined in operational terms and not in conceptual or dictionary definitions, meaning the researcher should define the variable according to what it means in the research, which shall enable him to properly classify or categorize the subject or any event. So examples of operational definition. There, for example, you have here the disease, rheumatic heart disease. So you describe operationally, you define. So a person shall be labeled a case of rheumatic heart disease if he has both of the following. You have stenosis and or insufficiency of the mitral and or aortic valves. Second is the history of rheumatic fever confirmed by the presence of carditis and or migratory polyarthritis, and an elevated ASO titer. So another definition that you would like to emphasize, like define obesity. It is an individual shall be considered obese if his weight is at least 10% in excess of his desired body weight. DBW, computed through the following formula. So your DBW in kilogram equals the height in centimeter minus 100 minus the height in centimeter minus 100 over 10. That is how you are going to define in operational definition of terms, so that you'll be able to identify what variables is that you'll be using. Is it the independent, dependent, the confounding, or the mutating? So what is an indicator? Indicators are the computed or collated collective characteristics of the persons making up the study populations. So specifying the variables aid in the planning of your data collection. So you have two. You have the measurements. This is according to mean, variance, and frequency distribution. According to count, rates, and ratios, disease occurrence such as incident rate, prevalence rate, and death rate. This is the specifying the indicators guide for data analysis. So let's try to go back again in the quantitative variable. Now, in the quantitative data or variable, there are two types under this. Again, to recall, we have the discrete and the continuous. Don't forget that one. So we have a post-test after this one. Now, levels of measurements. So there are 4 levels of data in increasing order of information. So under the qualitative levels, we have 2, the nominal and the ordinal. Under the quantitative levels, we have 2, interval and ratio. So the first letter spell as nowhere. So it's N-O-I-R. So levels of data. So when you talk about nominal data, these are pertains to names of categories only. So meaning to say that it's a categorical attributes only, no inherent order. Mathematical operations don't make sense. And of course, example, we have color and manufacturer, flavor, and etc. So that's how we talk about from the names. It comes from the root words name or categories, categorical in nature. So we need to say measuring the objects or events in a discrete category. So it is the most basic form of measurement. So used to categorize the data into different groups and mutually exclusive. And categories are no predefined order. So example, gender. So we have 2 only. We have male and female. So like for example, if you will ask the respondent, are you married? Yes or no? And you are from, is it urban or rural? Then your department, you will say marketing, HR, finance, sales. Then food habit, so you are vegetarian or non-vegetarian. Age, you have age bracket, you have below 20, 20 to 30, 31 to 40, above 40. But this sense that it's more on categorical data. So it's more on names of categories only. Okay, second level of data is what we know as ordinal. These are categories which also have order or rank or inherent order, no absolute numerical scale, and subtractions and divisions that make sense. So example for this are from the Likert type scale, like strongly agree, disagree, and strongly disagree. Sizes like extra small, small, medium, large, extra large. Places like first place, second place, third place, and etc. So this is an example of ordinal scale or ordinal data or level. Ordinal level. So a rank order of the data. Ordinal is the indication of order, logical hierarchy among variables. So not considering the magnitude of difference, arrange the data according to the relative position, ranking scale. My rank example here is rank your feature preferences when you buy a mobile phone. So example, you have feature there, mobile phone features like screen size, camera, processor, battery life, and memory. So according to your rank, the camera is number 1, number 2 is the screen size, battery life is 3rd, 4th is processor, and 5th is the memory. That's why the preferences when you buy a mobile phone. Another example is you rank the following mobile brand in order of your preferences. So you list down all the mobile phones features, like what are those mobile phones. You have Apple, Samsung, LG, Huawei, and OnePlus. So here categorized that Samsung is your rank number 1, and number 2 Apple, to be followed with OnePlus, and then you have Huawei and LG. Huawei and LG. I'm so sorry for that, my pronunciation. But another is what to rank, what internet, specific branding or that you would like. It could be internet, or it could be Wi-Fi you'll be using, or it could be aside from mobile phone, the types. But if there's a ranking that you would take into order consideration, so that is what we know as according to ordinal scale or ordinal data. Another type or level type is what we know as interval. Interval these are categories and order and scale. Addition and subtraction makes sense, and no natural zero. Multiplication and division don't make sense, but limited to dates and temperature. So again, in the interval, order as well as magnitude of difference. So difference between the two variables has meaningful interpretations. Distance between any two adjacent attributes is called an interval. The difference between the variables equal distance is a combination of these two scales. So it is a quantitative nature. So example for this, how important is price to you while buying a mobile phone? So you have here categories: most important, neutral, less important, less important for you. So you take note of which one is important for you when you buy a mobile phone. Another is the employees of organization are very friendly. You strongly agree, you're neutral, disagree, or you strongly agree. So another example, how likely it is that you would recommend your product to your friends and colleagues. So not all likely, you have scaling, and then extremely agree, or likely. You have in the middle, you have above, average, or below average. So that is what we know as an interval, and there's no natural zero. And the last level of data is what we know as ratio. This is the highest form, highest level of data, because it has category, order, scale, and natural zero. It could also be used as discrete or continuous. You can add, subtract, multiply, and divide. All can make sense. Example, counts, weight, height, and etc. So it is purely quantitative in nature, most precise, and holds all qualities of the scales, and most informative, purely numerical in nature. Example, age, specify age directly, weight, kilogram, then height, monthly income. So you specify immediately how it depends, as there is in organization. So this is one way also to determine directly. So scale difference between these two. In a scale difference for your ordinal or nominal, and as well as your ratio, this could be quite different from a lot of things that you need to consider also, because like for example, in nominal age, you will identify by names in categorical, but age here in ratio is directly you put the whole number, directly you indicate the exact number. So the statistical operations according to levels of data. Again, what are the levels of data? We have nominal, ordinal, interval, and ratio. So statistical operations, like if you use frequency distribution, all levels of data will be used: nominal, ordinal, interval, and ratio. For mode, ordinal, interval, and ratio. For the mean, you have two only. These are more on quantities, quantitative, no? Meaning there's a numerical measurement if you tend to use mean. So you have interval and ratio. You will use this level of data. In the calculation of difference, same. You have the internal and ratio because these are quantitative data. Additional subtraction, addition and subtraction, is focusing on interval and ratio. Multiplication and division only in ratio. For the range, you have three. You have from the ordinal, interval, and ratio. Standard deviation, you have two, only at the interval and ratio. Okay, so at the end of this recording, you will have the host test to identify the levels of measurements in ordinal, interval, and ratio. Data processing. How are raw data processed? Data processing begins with the organization of the raw data. Organizing is done by arranging the data in some logical sequence or grouping. If the number of items is few, the values of the observations may be arranged in array, like according to magnitude from the lowest to the highest or vice versa. If the number is large, the observations may be grouped according to some common characteristics, which would distinguish groups from one another. Data processing has become simple with the computer. Large amount of information can be entered in a data file and retrieved in tabulated form. There are 4 steps in computerized data processing. The first step is to edit. Editing is done by examining the completed forms or questionnaires to detect errors and omissions which are corrected by the following guidelines. It is in this step that the completeness, consistency, and accuracy are ensured. So editing is performed by the interviewers and the field supervisors. So again, the accuracy and reliability of the results depend on how well the editing and coding has been done. So editing and coding must be done with great thoroughness and care. So that is the editing. So as we all know that editing of data is the first step of data processing and analysis. After the collection of your data, either through the questionnaire or the interview schedule, or the schedule itself, you have to edit it. So you have to be carefully checked for missing and wrongly entered data. Therefore, in large-scale surveys and research, the company undertaking the research project appoints supervisors or editors for proper checking of the data. So an example of editing of data is given this situation. So example, suppose that you conduct a survey of the occupation status of the people in a village, for which you have to collect data from the heads of the households. So the questionnaire for the purpose is as follows. So the name of the respondent, so I'll just abbreviate. No, it's JR, and the age is 52. Alright, and sex is male, and occupation is private sector. Income of the respondent is 10,000 pesos, and the wife name is, I will abbreviate this one as GV, and the age is 49, and the occupation is housewife, and the monthly income is 800 pesos. Alright, so in this questionnaire, the wife of JR is a housewife, but she earns about 800 pesos. So she may be a housewife, but by this she is earning also about 800 per month. Therefore, Their occupation may be categorized as self-employment. Like this, you will have to cross-check the data and try to get an accurate information, which will minimize error and strengthen your research findings. Therefore, editing of the data is very essential before sending it for processing. Now let's proceed on the second step, which is what we know as coding. Okay, the second step is to code. Coding is the conversion of data into numbers or symbols, which can be more easily counted and tabulated. The objective of the coding is to make the data manageable and quantifiable. The success of the research ultimately will depend on the quality of the codes, as the original data no longer have any role after coding is completed. So encoding is done by trained individuals who follow prepared coding instructions. So again, the data should be filed in a way that allows easy retrieval when necessary. So the early preparation of dummy tables is a key step in the planning and pre-analysis phase of the study. So in this sense, you must prepare your dummy table as well. So as we go along in the coded, so when you talk about code, what do you mean by code? This is the numerical value that is assigned to a response at the time of analyzing the data. And coding is the process of assigning numerical values to different categories of respondent to a question for the purpose of analyzing them. And coding of the data, the questionnaire must be properly coded. Before either sending it for feeding into the computer or entering it in the master chart, the coding of the data is necessary. So the coding of data will make data entry easy. Coding of data means assigning numerical symbol to each response of the question. So the purpose of giving numerical symbols is to translate raw data into numerical data, which may be counted and tabulated. So an example of coding the marital status and education is like this. Example, marital status, married. So you put married as 1. Separated, let's say you label it 2, that is your code. Widow, 3. Divorce, 4. Never married, 5. Any other, 7. That's how you are going to write a code in numbering code. So the coding of data and checking that codes are properly inserted in the questionnaire and must be done during the editing of the questionnaire. It is always better to prepare a code book for your questionnaire. The coding can also be done during the time of data collection if the code book is available with you. So when you talk about code book, it's a listing of a set of numerical values or set of rows that you decided to assign to answers obtained from respondents in response to each question. It is what we know as a code, meaning you list all the information. So just like, for example, you want to identify the marriage status. So in order for you to be correctly identified of every answer of your respondents, you label it, you code it with numbers. So married, one, separated, and so forth. So you put or you write a number beside the box or after the labeling, so that for you you'll be able to understand well. So what about data entry or master chart? What does it mean? So in this sense, the third step is to create the data file. This is the storing of the data in punch card, disk, diskettes, or tapes, which can then be readily processed for analysis or filed for future use. So again, diskettes and disks are already obsolete now, tapes. But once you have the storage, internal hard drive, they can do that. But this is one way because the diskette is no longer used. This is the old one. And the final step is the processing, is to summarize the data prior to analysis or computation of the necessary parameters. Initial tabulation of the raw data has to be done. The output of the process are cross-tabulation and master tables, which permit the researcher to have preliminary overall view of the result. This is helpful in the analysis and interpretation of the findings. So in this sense, in the master, entering data in the master chart, if you are doing tabulation manually, it is always wise to enter the data into a master chart. So again, a master chart is a large sheet which will enable you to enter all the codes of different variables into it. It will help you to generate tables easily. An example of master chart is like this. Now, you have a table. You can do this in your Excel file. You can do that. So on the first column, you indicate the number. So you write all the numbers. Example, your variables for the number of respondents. No? Like for example, 5. So you write 1, 2, 3, 4, 5. Then the second column or column B, you indicate name of the respondent. So you indicate there because only you will know as the researcher. This confidentiality and ethical review is also necessary. This is only for your guide, as a researcher. And then the next column, these are your variables. So there's you can indicate sex, and then sex or gender, age, and then marital status, education, and occupation. These are your variables. That's how you will make it in a table form in your Excel file. So in the master chart, you can enter the data of 14 sample respondents. Then likewise, you can expand the number of respondents in the column and variables in the rows. It's always better to enter code in numerical number in the master chart. So you always indicate from the first question, from your questionnaire, the first question that you are in, you need to make or indicate the numbering or the code. So entering the data into the computer. So computers are widely used for the analysis of data. It makes the calculation much faster. The Excel sheet and the Spss package can be used in social science research, but then you can use also in your research.
So we are done with the master chart, and let's proceed on data cleaning. So in data cleaning, it involves the detection and removal, or what we know as the correction of errors and inconsistencies in a data set or a database due to the corruption or inaccurate entry of the data. So incomplete or inaccurate or irrelevant data is identified and then either replaced or modified or deleted. So in this sense, that incorrect or inconsistent data can create a number of problems which may lead to the drawing of the false conclusions. So therefore, data cleaning can be an important element in some data analysis situations. So however, data cleaning is not without risk and problems, including the loss of important information or valid data. So before you're going to delete or revise or make a modification in your data, make sure that you will have a backup. Okay? So as number one step, you should have a backup of your data before starting your data in the cleaning process, because there are a great risk that all the information are being deleted. So that's the disadvantage. So number two is to create a list of all variables. So you have the variable labels and variable codes. Third is you look for the coding errors. Fourth is look for outliers. Fifth is check for logical consistency of answers. Sixth is decide how to deal with incorrect or missing values options. So these are the following. Of course, number one is you have removing responses with the missing or incorrect values. Number 2 is to correct missing or incorrect data if the correct value is known. Third is going back to the data source and filling in the missing data variables. And last would be is setting values to answer or to a favorable average within the statistics or statistical values. So you retain that you want so that all the information that you have are set properly before planning on data cleaning or deleting your important information.
Here, box 15.2 examples of coding expression. So, before we introduce this one, I would like to emphasize on the manual coding and data entry. So, if the questionnaires are self-completed manually, just like postal, then they will need coding entirely in the office. So, interview data can also be hand-coded by the interviewer during and after the interview, or what we know as field coding, directly on to the paper questionnaire. However, it usually requires coding for the coding to be completed back in the office by a coder or a team of independent coders. So generally, because it takes place in a less rush routine setting and it's usually less prone to coding errors, so some also simple self-completion questionnaires do not require further coding if the respondent has already ticked the numerical code corresponding to his or her reply. But in rare cases, to be able to dispense with office coding completely, as most questionnaires allow for the later coding of other response categories or any open-ended questions that have been included in the questionnaire. So the codes may be entered by the coder onto the questionnaire in the boxes designed for this, usually in the right-hand margin, or in clearly labeled coding boxes on a separate coding transfer sheet. So the use of this increases the cost of the study, specifically good for the design, paper, and printing. That has the advantage that the questionnaire is less visually cluttered by the omission of the coding boxes. So coding boxes are allocated for each question, so each box must contain only one number. Thus, for answers which have been allocated a 2-digit code, meaning you have the number of and expected the numbers will be indicated there, and 2 boxes or coding boxes will be provided, one for each number. So if more boxes are provided, then there are numbers in the answer recorded in the questionnaire, then it should be written on into the boxes preceding to the first number of the response. So for coding transfer sheets, so the paper or electronic coding sheets used for data input will either be completed. So pre-coded questionnaires or coding transfer sheet for each questionnaire, which contain the transferred codes from each question. So the latter part are used if the investigator does not wish to clutter the question with numerical codes and coding boxes, though this then doubles the administrative effort and paper cost. So if you notice an example of coding transfer, you have the question here, you have the serial number. The first question is where, so specialist. Number 2, given a choice, and you have the coding boxes, you label it there, and you have the variable name. The example is the serial number, that's your variable name, and Q1 meaning question number 1, that's is specialist or spec, and question number 2, that is the choice. So that is one way to determine how you're going to give or emphasize on the coding. So both methods must indicate exactly where in the individual's computer record each item of data is to be placed. This is also usually done by allocating variable names to each question, which are stored in the computer's data entries program or in a predefined sequence, as well as on the coding frame, or the variable name is usually a summary of the question in 8 or less digits and for question number. So in box 15.3, an example of the code book, So as we all know, that code book of the data should be prepared, and this is a master copy of the questionnaire. And with the question number, the question, the full range of valid codes written in, including missing and do not apply values known as value labels by computer packages. So the number of columns available for each response, or the code boxes for transfer to the computer columns, and the variable label, which will be required for its identification on the computer, usually a maximum of 8 digits. So either the question number can be used for the variable label or a short word, like for example the word class would be used to identify social class code. So in this sense, some investigators also write these details by hand or onto a copy of the questionnaire. Others will also retype and the entire code book if all the codes are already known and typed onto the questionnaire before it was printed. And if the coding boxes are already known and printed in the right-hand margin, then a few hand additions of extra codes and the variable names are all that is needed. So the code book is needed for coding and reference. So this is an example of your code book. So you have the questionnaire for patient, you have the master copy code book, you have the serial number and the first question, where did you see the specialist this time? So there's a specific numbering, and you have the code boxes, and you have the variable name, serial number, and the question 1 for the specialist. And question number 2, did your general practitioner offer you the choice of seeing a specialist in the general practitioner's surgery or at the hospital? You have a yes or no and the missing response. So there's a specific code for that, and you have the variable name, which is question number 2. So that is one way also to make your coding or code. Alright, so why computer in data processing and analysis? So you have here, of course, it takes time, and you also maximize its resources and energy, and this is also to minimize or lessen errors or biases and use of advanced tools. So data processing may be done by manually, mechanically, or electronic, or via computers. Means when the research is simple and the number of variables is limited, manual processing is possible. But as the research becomes more complex and the number of variables increases, manual processing may no longer be adequate. So computerization makes processing and analysis simple or simpler and more accurate. But the mechanical processing was useful before the age of the computer. So today it's already obsolete, and today, because of the computers mainly revolutionize data processing and analysis. They have made the process simpler and better. So some steps could contribute to errors, such as the preparation of index tables, have been rendered unnecessary. So you have also cross tabulations, which are very helpful in analysis and easily done by the computers. So you can save more time and have lots of resources, saves energy, and this is also to prevent from errors and the use of advanced tools, because you have more tools here this time with the use of computer. So let's talk about coding. So in coding, so we already discussed that there is assigning of numericals and labels. So in numerical values for codes, in quantitative analysis, this requires the information gathered to be coded either quantitatively, so in the form of measurements such as weight in kilograms or age in years, or in qualitatively, like in the form of homogeneous category, so that the numbers in each group can be counted. Thus, for example, for sex, the groups are already categorized into male and female. For marital status, the groups are married, cohabiting, single, or widow, or divorced, or separated. And it was pointed out that each of these code or coded groups will require a numeric value before it can be entered onto the computer, and it will be counted also and analyzed. So in the numerical value, you will explain there that this either be quantitative or qualitative. So in the structured or pre-coded instrument, in this sense that when you code so when you talk about structured, is it closed questions or is it open questions? So these are more focusing on the closed questions for the structured one. So coding closed questions. So closed questions require that any grouping should be defined before the data are collected. So before the data are being collected, so it should be properly defined, and the response is then allocated to the predefined category with also a number assigned. So the response is then itself an item of data ready for transfer for coding boxes, and also for your data entry and analysis. So for example, yes, that would be you assign the code that is number 1 and no, that is number 2. It is important at the design stage of the questionnaire to ensure that a recorded response is always requested. So for example, if the questionnaire simply asks respondents to tick items that apply to them, so it will be unknown whether unticked items imply and no response, or whether the response or respondent forgot or declined to answer them. So it was pointed out that some survey organizations give interviewers laptop computers, and respondents' replies to closed questions are entered and automatically coded, ready for data processing back in the office. This requires a prior construction of the coding schedule or the frame, and is possible only with high structured surveys where the subject is well known and as are likely responses. It is more common for coding to be transferred or carried out in the office by hand. So an instruction sheet for coders is usually designed which may on the coding frame, which clarifies any likely ambiguities and specifies how the coding is to be carried out. So computers will generally be used to code data that are already in numerical form. So for example, you have age from date of birth, and coding into age groups after initial analysis of relevant cutoff points. So that is your structured pre-coded instrument. Whereas in the unstructured questions, what does it mean in the unstructured questions? So in this sense, these are examples mostly for coding for open questions. For open questions, it will allow respondents to use their own words and form their own response categories. So responses must then be listed by the investigator after the data has been collected, then grouped by a theme for the development of an appropriate coding frame. So this can be often be done on the basis of analyzing a random sample of 30 to 50 questionnaires, and then testing the coding frame on further batches. So only then can coding take place. So even with a largely structured questionnaire with a pre-coded response choices, so there is likely to be a need to list and develop a coding frame for the various or other. So you will specify or please state why. So that is for your safety net. Response choices that were offered to respondents whose replies did not fit the code or the codes given. So examples of data obtained from open-ended questions is in patients' self-administered questions about their visit to specialist clinics and general practice. This is according to Bowling et al. In 1995b. So that is mainly the example in the box just shown, previous box. So the expectations given by most of the patients in the study, about 400, were fairly similar and are multiple response coding frame with numerical codes attached was easily developed for them. Like for example, you have the diagnosis and labeling of problem, that is number 1, and then cure for number 2, treatment or surgery is cure, that is number 3, procedure or surgery for investigation, that is 4, and so on. So not all comments was being mentioned there, so are concise as this, and they often require more than one code, or what we know as multi-codes, to ensure that all items mentioned have been accounted for. So another example, at the end of the same questionnaire, the patients were asked if they would like to make any other comments about their visit to the specialist clinics, and many wrote a quarter to half a page of comments. So that's the difference for the open questions. Alright? For another thing is coding according to research objectives. So as we all know that everything should be taken place of what are your objectives, that would be your guide, so that you'll be able to code as well specific objectives, and also corresponds to the specific variables. Right? So numerical coding should be most appropriate. Okay, for the data entry, so you have the master chart or table. So in the Excel file, you can use this one. You can make a dummy table and chart for you to be guided. You can indicate, just like for example, your respondents are 5 or 10, so you list down the items 1 to 10 or 1 to 5, and then the first is your respondent, so you list all your respondents, and then next column and succeeding are your variables. So variables in column and cases in rows, and data entry, you will use MS Excel, and it's easier because there is a tabulation already of the columns in rows, and also integration of codebook and master. So from your codebook, you already have your guide, and these are your variables, and these are the things that upon your data collection, you already gather information. So you have also your master chart, and reading Excel data in SPSS. And in the SPSS, so it's a software. So you need to there is a specific tips on how to use this SPSS, so that the final output is presented in a specific table or graph, and it will easier for you to explain, and once it will be transcribed. So before you are going to enter any data in the SPSS, you should need to think about what type of data you have and what you want to do with it. So for example, you may have the details of a person's gender, male or female, and their preference for a certain product, or you may have collected a set of reaction times. So are you trying to find differences within your data or any relationships, or do you just want to summarize and describe it? So what is the level of data? Is it nominal, where the data is labeled by the category it belongs to, such as car color, or ordinal, where the data defines an order, such as rating a group of vegetables on how much you like them, or you have interval or ratio, where the data is measured on a scale of equal intervals, like a timer or a tape measure. So this needs to be considered before entering any data. So if you have nominal data, you may need to use this as a grouping variable when entering the data in SPSS. So we can explain the use of a grouping variable with the following example. If you were going to calculate statistics by hand, you would probably write the scores of males and females on a mathematics test in the following fashion or table. So example, you have the person number 1, 2, 3, 4, 5. That is your first column, and the rows is 1, 2, 3, 4, 5. And then you have your male. So you list down all the digits, and you have person number, the next column, and then female. So you notice that the variable gender is measured as a nominal scale. So there is two categories. You have male and female, and the variable math score is measured on an interval scale. So gender in our grouping variable, because it defines our two groups. So we would like also to compare later on the math scores between these two groups. So again, you'll be using this SPSS. Then you need also to give the values of the grouping variable a label, so that you will allocate the males and the arbitrary number 1, and the females is the number 2. So when you do enter data into the SPSS, it will look similar to the data which you are going to see in your SPSS. So you will have person 1 to 10, then gender. There is a specific number. Is it male? So you indicate once the gender is male or female. So if male is number 1 and females is number 2, you will identify any specific math group or math score. What I mean is math score. So in analyzing data in SPSS, we can employ an independent variable as a grouping variable. This separates our participants into groups such as introverts versus extroverts. It is important also when inputting data into a statistical analysis program that we include the grouping variable as a column with each group defined. Introvert that has 1 and extrovert as 2. So we can then analyze the scores and other variables in terms of these groups, such as comparing the introverts with the extroverts, or in a say that monitoring task. That is only an example. Now, if you're using this data entry with the use of this SPSS.
Data cleaning. So this data cleaning is correcting also errors in data entry, and also we have this maximum and minimum and frequency and etc., and also sorting and correcting. So what does this data cleaning is important? Why it's important for us to decide on how to clean the data for processing it for analytical or statistical use. So data cleaning is the process of preparing data for analysis by removing or modifying data that is correct, and also those who are incomplete and irrelevant, and also those data that has duplication or improper formatting. And because of this may hinder, or there will be a problem in the process, or this could lead to provide inaccurate results. So what are these considerations that need to take place? So in distinguishing errors from the input data, and also we will check on data compatibility, and if there are missing values or data, and also outlier detection and malicious data, there's improper code or typing errors, and also category merging, and if there's logical errors and errors that erroneous data may come in, and there is also irrelevant data, inconsistent data, and of course formatting and missing frequency. So how to do this in correcting errors in data? entries. So it happens routinely, and mistakes, even human error takes place, and mistakes is taking through the entry of data. So how to solve this is the use of your descriptive statistics. You can do this with the minimum, maximum, and range through the like scale. So like for example, you have 7 to 8, then you can determine that there is really mistakes. So once you do this, you can do also random checks, and this is the most crucial part because you need to identify and putting on the entries that you want to clean and to revise, or this is also to help you to random check, and so that there's a possibility that you need to go back to get again data or to go along with the survey, and you can redo before finalizing and all if there is errors, and so that this is also to prevent from false results, and you can do this by fixing, and you can go back to the original survey and sorting out and correcting. So in correcting, you need to fix and you need to sort it out what is important, who are those data that needed, and because in data cleaning you need to give the important element for your data analysis. So before you can go on and process for statistical use, then you need to be validated on the important information, and valid data should be obtained. So again, as what I mentioned earlier, you should have backup of your data for saving, also for the pertinent information before you can proceed on the cleaning process. And of course, list all your variables and double check. And I think the most important thing is you must prepare a external hard drive so that you can store. There's a proper storage also of your data. And look for coding errors. So in a coding part, you need to take note what are those that needs to be corrected. Take note on the coding errors and outliers as what I mentioned earlier. Check for logical consequence or consistency of answers, and you decide how to deal with the incorrect one or the missing values, and there are options that you need to consider also. And again, in coding, to code you need to be systematic and giving corrections so that proper putting of the correct data will be stored for data analysis and statistical computation later on, so that you can identify the correct statistical tools that you'll be using. That's its data cleaning. What is analysis or data analysis? So data analysis consists of computations of the desired indicators stipulated in the specific objectives of the study. It is also a simply routinary operation when the research is conceived and planned properly. So a well-planned research includes a properly planned method of analysis. So new and stronger statistical methods and tests are continuously being developed. Their use, however, is subject to strict rules. So this topic we'll be discussing on explaining the one with the other, and through association and relationship with linear versus non-linear, and also comparison of two or more groups, and as well as hypothesis testing. Sorry. So the output of the analysis enables the researcher to readily interpret the results of the study and answer. So we have here the sub-problems. Consequently, you can formulate answers or solutions to the general health problems. So statistical analysis is either descriptive statistics or what we know as inferential statistics. So we'll be discussing that one or that part on the later slide. So what is descriptive statistics and what is inferential statistics? But beforehand, let's talk about what are the common indicators used in medical research. So let us define variables again. So these are characteristics of the individuals or subjects which vary from person to person or in the same person at different times. So examples are age, sex, occupation, height, weight, red blood cell counts, blood sugar levels, and these are part of your variables. We can determine variables are your independent variable, dependent variable, and your mediating or your confounding variables. The second term that we use to be as an indicators is what we know as our research indicators. These are computed or collated collective characteristics of the person making up the study population. So examples are the mean, the variance, and frequency distribution of the measurements or values of the variables. So you have the rates and ratios of disease occurrence or even deaths. And we have also parameters. These are indicators derived from the entire population or universe. So statistics are indicators derived from a sample of the population. So variables commonly measured in research may be classified into 4 categories. These are what we know as scales of measurements. So in the scales of measurements, as we recall, we will be able to identify 4 scales. So we have nominal, ordinal, interval, and ratio. So as we described, when we talk about nominal, this classifies subjects into one of a number of qualitative classes. So examples are sex, nationality, and religion. In the ordinal scale, these are similar to nominal, but classes can be round. So we have social class, profession, nutritional status. In the interval, this is the exact distance between 2 categories. It can be determined by the 0-point arbitrary. So we have example, temperature, and examination score. And the ratio is similar to interval, but the 0-point is fixed. So we have here like age, the height, the weight. So the common indicators used in health and medical research are the following. We have number 1, measures of central tendency. This is the most useful, are the mean and the median. Measures of variation. This includes the range, the variance, standard error, and etc. The frequency distribution. This is the proportion of subjects found in the different classes of the population. For the rates, and ratios, these measure the frequency of occurrence of events out of the total possible occurrence. So how these indicators are computed? So we'll be showing to you in the later part of this all about statistics. So why is statistical testing performed? So a statistic is expected to vary from parameter simply because it's derived from a sample. So the variation is called sampling error, or these are your variation, also referred to as a chance or chance of variation. The objective of statistical testing is to determine if an observed difference between a statistic from a sample and the parameter, or between 2 or more statistics from different samples, is small enough, is to be attributable to sampling variation. So if the difference is likely to be due to sampling variation, the statistical test will show a statistically significant difference with a p-value of less than 0.05 is the usual standard, and this difference is attributed to sampling variation or chance. So if the difference is large, meaning the p-value is more than or equal to 0.05, it cannot be due to sampling variation alone. So it is considered as statistically significant. So it is interpreted as a true difference and attributed into something other than sampling variation or chance. It is attributable to the factor being tested on the assumption that the study is done properly. So let's try to recall on the association. What are these associations? If we can go on with the parameters and how to do with the computation of these measurements. So to measure the variation, we understand that one already, but we will try to do on the association as an indicator. So measures of degree of association. So we have here the first one is a cohort study. So what does this cohort study all about? So if we can see that the association of a cohort, so you have the relatively risk. So in the sense that this study is designed to test the hypothesis of relationship by comparing the frequency of the outcome in those with a factor, meaning the exposed, and those without the factor, or what we know as the unexposed. The cohort study starts from the suspected cause and routes forward and the outcome. So the researcher selects a study population and subjects, the members, to preliminary screening. Those who already have the outcome are excluded, and those who qualify are grouped into two, those with the factor and those without the factor. The two groups are followed for a given period of time to identify members who will develop the outcome. So this is done through re-examinations or surveillance. This type of cohort study is also known as your concurrent cohort, or what we know as the prospective cohort study. It uses primary data, sometimes in the latent period of the disease or process, as long as it is therefore not practical to use primary data. Whereas for those previously collected data, meaning secondary data, such as the hospital records, may be used after the population has been pre-classified as having or not a factor. This is what we know as our non-concurrent or retrospective cohort study. So in the analysis of data include computation and comparison of frequencies of occurrence of outcomes and the relative risk of developing the outcome. So that is why in our computation, as we can see in the computation of the cohort study, so we will identify on the degree of association. So we have two formula for us to be guided. So we have here the first one is the relative risk. So it represents R or double R. This is the ratio of the frequency of the disease among those exposed, the frequency among those not exposed. So you have RR or double R equals P2 over P1 or divided by P1. So meaning to say P1 is the frequency among the unexposed, and then P2 is the frequency among the exposed. So again, P2 over P1 or P2 divided by P1. That is to determine the relative risk for those who are exposed versus the non-exposed. The second one is the attributable risk. Does it mean this absolute frequency of the disease is in the exposed individuals that can be attributed to the exposed? So attributable risk, so we have AR is equal to P2 minus P1. So this is to measure the degree of association under the cohort study. let's proceed on the case control study. In the case control study, what does it mean? So here in this study, it compares the frequency of the factor among those who are in outcome and those without the outcome. So the researcher initially selects the cases from this chosen population, like all cases in the community, only severe cases, and etc. So the case are individuals with the outcome or effect. Then he selects individuals without the outcome or effect as controls. In general, if this represents all persons in the community who are sick of this disease under investigation, controls should be drawn from the community where the cases came from. If the cases are chosen from the admission in respected hospitals, so controls should likewise be chosen in the same hospitals as the cases. This is an attempt to minimize the influence of selection bias. The case and the controls are questioned regarding the factor under the study or dependent variable. This is the assessment of the factors shown in the case control study. So analysis of the study include the determination and comparison of the frequency of the factor in the subjects and the control. So odds ratio or relative risk of developing the outcome for those with the factor or relative to those without can also be computed. So in this sense that a case control requires two populations, one with the outcome and the other without the outcome. So an example of this is the computation about odds ratio and the cross product ratio. This is the rate of experiencing the outcome when an individual is exposed relative to being unexposed. So you have a certain factor with a positive and a negative. The second column where you write down the case A, and then next is case C, and then control or B. Or you can do this as A times D over B times C. That is the odds ratio or OR equals to A times D over B times C. That's the case control study. Another one is the experimental or the intervention study. So the difference of this experimental, this is another measurement or statistical wherein that in the experimental or experiments are the strongest of all the study designs because they provide the most control over the study situation. They enable the researcher to isolate the observed effect of the study factor or the intervention. So an experiment differs from a cohort study with the investigators significant factors to consider. And there is also the researcher follows the same procedure in a cohort study except that he chooses the study population on the factor of the intervention. So he then assigns the subject into the two groups by scientific technique. He introduces the intervention to one group and withhold it from the other. So randomization of the intervention equalizes the distribution of the extraneous factors. If randomization is not done, the study is only a quasi-experiment. So in the laboratory, the researcher can hold the extraneous factors fixed for all the subjects. So randomization of the study factors adds the strength of the experiment. So all experiments are supposed to be prospective. However, there are sometimes situations occurring naturally, which also simulate the same conditions or those that are prescribed in an experiment in which the researcher can exploit to do his study. So sense, there will be no opportunity for randomization. So this is what we know as our natural experiment. So in this sense, that the formula you'll be using is the protective value. So in the protective value, this is the amount of reduction in the risk of experiencing the amount when an individual is given the intervention or prevention measure or treatment. So protective value, meaning PV, is equal to P1 minus P2 over P1, wherein P1 is the frequency among those not given the intervention, whereas in P2 is our frequency among those given with the intervention. Meaning to say, the protective value, one would have an individual without given with the intervention, and the other also not given with the intervention. Another variable to consider, the means of association, is through the correlation and regression analysis. In this sense, that correlation between two variables exists where there is concomitant variation in the frequencies of two variables, with the high values of one variable is associated with the high values of the other variable, and the low values of the low values of the other. The association is positive. It is negative when small values of one is associated or are associated with the high values of the other. So a regression problem considers the values of the measurement when another is held fixed at each of several levels. So the estimating equation formula, we are divided into two. We have the linear relationship and the non-linear relationship. In the linear relationship, so you have the y is equal to a plus b x. So wherein x is the dependent variable, the y is the dependent variable, the x is the independent variable, the a is the intercept constant, and b is the slope or the rate of change. Whereas in the nonlinear, the variable depending on the configuration of the curve, meaning the degree of association, is measured by the coefficient of correlation, the formula for which is, so we have r is equal to the summation times the x minus x squared to the sum of the x times y minus the sum of y over the summation of x minus the sum of x squared and the summation of y, the sum of y squared, wherein y is the dependent variable, summation of y mean of the dependent variable, the x is the independent variable, the summation of x mean of independent variable. So these are partly of your relationship between linear and non-linear association. So to further explain on the comparison of two or more groups, we will also tackle on during the statistics, or what are the comparisons of two or more groups associated. So in the hypothesis testing, so when we talk about hypothesis, it's a suggested or a tentative answer to your research problem. Usually a researcher has some ideas to what the problem, but the general problems and sub-problems of this intended formulating these answers in the form of narrative sentence. So there are two types of the hypothesis. You have the null hypothesis and the alternative hypothesis, or what we know as positive alternative or the positive hypothesis. So when we talk about null hypothesis, is one that assumes the association that does not exist, such as example is not different from the population, or the independent variable or suspected cause is not associated with the dependent. A sample is not different from a population, and the independent variables or suspected cause is not associated with the dependent variable or with the outcome. Or an intervention in effect is not effective or more effective than another intervention. So this is your null hypothesis. And the alternative or positive hypothesis is the opposite of the null hypothesis. So it assumes that an association exists. So there are two types under the alternative or positive. We have the two-tailed or the non-directional alternative hypothesis. This does not indicate direction of association, such as whether it is direct or inverse, in which it is greater when two samples are being compared. Whereas in the one-tailed or directional alternative hypothesis gives the direction of the relationship or states which is greater when two samples are being compared. So that is an example what this means under the two or types of alternative or positive hypothesis. We have the two-tailed or the non-directional or one-tailed, which is the directional alternative or positive hypothesis. So in this working hypothesis, in study has to be formulated. The null hypothesis should be used for testing for the safety of drugs and other interventions, also for proving to a health or medical need or erroneous. So in the alternative or positive hypothesis, this is preferred in testing in suspected risk and prognostic factors, as well as the intervention. It's not logical to use null hypothesis for this purpose, unless the literature shows conflicting findings on the subject. And in this sense, warranted by the data, so one-tailed hypothesis is better and should be formulated instead of the two-tailed hypothesis. So in the hypothesis also, formulation begins with the identification of factors which may have a relationship with the outcome of interest. So the factors identified through the analysis of data from existing descriptive and cross-sectional studies. If there are no such studies, then they have to be done before a logical hypothesis can be formulated. So in this sense that to get a population or sample with a high frequency of the outcome in a population with low frequency of the outcome, to look for the factors which are prevalent in the first and non-prevalent in the second. So such factors can be suspected of having something to do with the occurrence of the outcome. This approach is what we know as the method of difference. So once you search for an outcome with a similar pattern of occurrence as that of the outcome of interest, the causation of the first is known or established. A hypothesis of relationship similar to this causation may be formulated. This method also is what we know as analogy. So if the occurrence of the outcome of interest fluctuates, then look for the factors that corresponding fluctuates. So such factors could be causally related to the outcome. This is what we know as the concomitant variation. So examine the distribution of the outcome according to the different descriptive variables such as a person, time or place, then look for the factors that are similarly distributed or fellow travelers of the outcome, and they are possible causes of the outcome. This is what we know as the method of agreement. So as a factor has been identified, then it may be incorporated in each question or subsequent question or sub-questions, which is restated in declarative form in order to in the form of hypothesis. And if information on the degree of relationship is available, the value to include is in the hypothesis. So you need to restate. that is your hypothesis testing. So we will discuss on the choice of techniques. So we will be discussing on sampling design, wherein the random versus the non-random. We have also the nature of variable. We are done with the discussing with the nominal, ordinal, and interval, and also the number of variables or the number of cases for the sample size. So as we all know that we talk about sampling is therefore the process of selecting a few, meaning a sample, from a bigger group, meaning the sampling population, to become the basis for estimating or predicting the prevalence of an unknown piece of information or a situation or outcome regarding the bigger group. So this process of selecting a sample from the total population has advantages and disadvantages. So the advantage are those that it saves time as well as financial and human resources. However, the disadvantage is that you do not find out the information about the population's characteristics of interest to you, but only to estimate or predict them. Hence, the possibility of an error in your estimation exists. So let's try to define some terminology. So when we talk about the class, families living in the city, or the class family living in a city from which you select your sample are what we known as your population or your study population. These are denoted as the letter N. So when we talk about the small group of students, families, and from whom you collect the required information to estimate the average age of the class or average income or the election outcome, is what we known as sample. Whereas the number of students, families, and from whom you obtain the required information is called what is your sample size, and it is usually noted as the letter N, small n. So the way you select students or families are called as your sample design or sampling strategy. So each student family becomes the basis for selecting your sample is what we know as your sampling unit or sampling element. A list identifying each student family and the study population is called your sampling frame. If all elements in the sampling population cannot be individually identified, then you cannot have a sampling frame for that study population. So your findings based on the information obtained from the respondents with your sample is what we know as your sample statistics. So your sample statistics become the basis of estimating the prevalence of the above characteristics and study population. So your main aim here is to find answers to the research questions in the study population, not the sample you collect information from. So from sample statistics, we make an estimate of the answers to our research question in the study population. The estimates arrived at from sample statistics are what we know as the population parameters or the population mean. So there are principles of sampling. The theory of sampling is effectively explained as given example. Suppose there are 4 individuals like A, B, C, and D. Suppose that A is 18 years of age and B is 25. As their ages, you can find out or calculate their average age by simply adding 18 plus 20 plus 23 plus 25 is equivalent to 86 and divided into 4. So there are 4 individuals. This gives the average mean age of A, B, C as 21.5 years. So now let us suppose that we want to select a sample of 2 individuals to make an estimate of the average age of the 4 individuals. So to select an unbiased sample, we need to ensure that each student has equal and 2, that's 21.5 years. Another is B and C, that's 20 plus 23, that's equivalent to 43 divided by 2. So we have 21.5 years. So another is B plus D, that's 20 plus 25, that's 45 divided by 2, that's 22.5 years. So another is C and D, that's 23 plus 25, that's equivalent to 48 divided by 2, that's 24 years. Now, you notice that the most cases, the average age calculated on the basis of the samples of 2 is what we know as your sample statistics is different. Now, compare the sample statistics with the average of all 4 individuals. The population mean, or the population parameter of 21.5 years out of a total of 6 possible sample combinations. Only in the case of 2 is there is no difference between the sample statistics and the sample mean. Where there is a difference, this is attributed to the sample and is known as sampling error. Again, the size of the sampling error varies markedly. So let's take a look at this. In the principle 1, in a majority of cases of sampling, there will be a difference between the sample statistics and the true population mean, which is attributable to the selection of the units in the sample. So to understand this, the second principle, let us continue with the above, but instead of sample of 2, take a sample of 3. So there are 4 possible combinations of 3 that can be drawn. A plus B plus C, that's 18 plus 20 plus 53, that's 61 divided by 3. So we have an average of 20.52 years. Another is A plus B plus D, that's 18 plus 20 plus 25, that's 63 divided by 3. So that's 21 years. Another is A plus C plus D equals 15 plus 23 plus 25, that's 66 divided by 3. That's 22 years. And B plus C plus D, that's 20 plus 23 plus 25, that's 68 divided by 3. So that's 22.67 years. So let us compare now the sample statistics and the sample mean. So compare the difference calculated from the previous sample. So wherein the sample statistics and sample mean lies between minus 2.5 and plus 2.5 years, whereas in the second is between minus 1.17 and plus 1.17 years. So the gap between the sample statistics and the sample mean is reduced. So this reduction is attributed to the increase in the sample size. So this leads to the second principle, meaning the greater the sample size, the more accurate the estimate of the true population. So in the third principle of sampling is particularly important as the number of sampling strategies such as stratified and cluster sampling. To understand this, let us continue, but we'll try to revise or slightly have a different data. So A is 18, B is instead of 23, we'll make it 26, and C is 32, and D is 40. In other words, we are visualizing the population for the individuals with respect to each. The variable they're interested in is also different. Will have a different output. So in this sense, that same procedure, selecting samples of 2 at time and then 3. So if we work through the same procedures, so we'll find the difference in average age in the sample of the 2 ranges between minus 7 and plus 7 years. In the case of the sample of 3 ranges between minus 3.67 and plus 3.67. In both cases, the range of the difference is greater than for the previously calculated. This is attributable to the greater difference in the age of 4 individuals in the sampling population. In other words, the sampling population is more on heterogeneous, meaning disparate or diverse in regards to age. So principle number 3, the greater the difference in the variable under the study in the population for a given sample size, the greater the difference between the sample principal statistics and the true population mean. So these principles are very crucial, and keep in mind that to determining the sample size, and this is needed for a particular level of accuracy, and also in selecting the sample strategy that is best suited to your studies. So here, in the sense that the aim of selecting a sample, to select a sample in quantitative studies, you are primarily aiming to achieve a maximum precision in your estimates within a given sample size, and is also to avoid bias in the selection of your sample. So bias in the selection of a sample before is sampling is done by non-random method. That is, if the selection is consciously or unconsciously influenced by human choice, or the sampling frame, like the list or index or other population records, which serve as the basis of selection, does not cover the sampling population accurately and completely. Another is the section of a sampling population is impossible to find or it refuses to cooperate. So we already know the different types of sampling in quantitative research. So we have here the random or probability sampling designs. This is what we know as random sampling or the probability sampling. Is the lies on the probability of the selection of each element in the population is the same. That is, the choice of an element in the sample is not influenced by other considerations such as the personal preference. So in this sense, you have also methods of drawing a random sample. We have visual draw. So this means that the total population is small. An easy procedure is to number each element using separate slips of paper for each element. Put all the slips into a box and then pick them out by not or looking on it until the number of slips selected equals the number sample size you decided to find. So another is the computer program. There are a number of programs that can help you to select a random sample. So another is the table of randomly generated numbers. So most books on research methodology and statistics include a table of randomly generated numbers in their appendices. You can use that one as your sample using these tables according to the procedure. So the procedure of selecting a sample using a table random numbers. So let's illustrate, like for example, for random numbers, let us assume that your sampling population consists of 256 individuals. So number each individual from 1 to 256. Randomly select the starting page set of column 1 to 10 or row from the table, and then identify 3 columns or rows of numbers. So that's how you are going to do that. Suppose you identified the 9th column of numbers and the last 3 digits of this column are underlined. Assume that you are selecting 10% of the total population of your sample, so 25 elements. So let us go through the numbers underlined in the 9th set of columns. First number is 049, which is below 256 for your total population. So hence the 49th element becomes a part of your sample. So the second number is 319. It's more than the total elements of your population, which is 256. Hence you can accept 319th element in the sample. So the sample applies the next element. So 758, and you did the next 5, and you did in the next 5 elements 589, 507, 483, 487, and 540. After 540 is 232, and if this number is within the sampling range, so it can be accepted as part of the sample. Similarly, if you follow down the same 3 digits in the same column, we select 052, 029, 065, 46, and 161 before you come to the element of 029 again. As the 29th element has already been selected, go to the next number and so on until 25 elements have been chosen. So once you have reached the end of a column, you can either move to the next set of columns or randomly select another one in order to continue the process of selection. So you can also select on 25 elements or are selected for the 9th, 10th, and 2nd columns. So that's how you're going to do randomly select. So sampling with or without replacement. In random sampling, it can be selected using two different systems. So we have sampling without replacement and sampling with replacement. So suppose you want to select a sample of 20 students out of a total of 80. The first student is selected out of the total class. And so the probability of selection of the first student is 1 over 80. So when you select the second student, there are only 79 left in the class. The probability of selection of the second student is not 1 over 80, but it's 1 over 79. So the probability of selecting the next student is 1 over 78. So by the time you select the 20th student, the probability of his or her selection is 1 over 61. So this type of sampling is called sampling without replacement. But in contrary, the basic definition of randomization that is each element has an equal and independent chance of selection. So in the second system called a sampling with replacement, the selected element is replaced. The sampling population is selected again and it is discarded. The next one is selected. If the sampling population is fairly large, then the probability of selecting the same element twice is fairly remote. So sampling techniques. So sampling again is a procedure of drawing a fraction or segment of the population for the purpose of determining certain characteristics of the population or the occurrence of some events in that population. Even if this were possible to include the entire population in the study, frequently we lack the resources to do so. So besides the economic advantage of sampling, it is obvious that greater speed in getting results is attained. Likewise, it is impractical to include each and every member of the population in investigation. It requires complicated and highly technical procedures and highly skilled personnel. So in such studies, greater accuracy is achieved and more information is obtained with a sample than with the entire population, since more intensive and careful data collection and analysis can be done with limited subjects. So the sampling scheme is a combination of sampling techniques where the study population is very large sampling and may be done by stages or multi-stage sampling. So accuracy of results is greatly affected by the methods of sampling. So we have commonly or types of random sampling. So we have simple random sampling. We have also stratified random sampling and as well as the cluster sampling. So again, as we recall, in the random sampling, this is a method of selecting a number of subjects and units from a population or universe such that every member has an equal chance of being drawn into the sample. In practice, this is done by drawing the sample unit by unit. The unit is numbered 1 to n. 1 to n. So the sample is drawn either by means of a table of random numbers or by placing numbers 1 to n in a container. So mixing thoroughly and drawing the n numbers in succession. So at any stage in the draw, this process gives an equal chance selecting to all numbers or members not previously drawn. So that is what we know as simple random sampling. So simple random sampling, or SRS, is the most commonly used method of selecting a probability sample. In line with this is the definition of randomization. Each element in the population is given an equal and independent chance of selection. That is what we know as simple random sampling. In the stratified random sampling, is the accuracy of your estimate largely depends on the extent of the variability or heterogeneity of the study population with respect of the characteristics and a strong correlation with what you are trying to ascertain. So just like in principle number 3, follows therefore that if the heterogeneity in the population can be reduced in some density for a given sample size, you can achieve greater accuracy in your estimate. Stratified sampling or random sampling is based upon this logic. So here in this method, the population is divided into subpopulations or strata. So samples from each stratum are then selected either by random or systematic sampling, and if the stratum is a population by itself, then the whole procedure are described as stratified random sampling and stratified systematic sampling respectively. So to obtain optimum results from stratification, the sizes of the population on each stratum should be allocated proportionately. So in other words, if a stratum is 10% of the entire population, then 10% of the entire sample must come from this stratum. If another is 50% of the total, then 15% of the sample must be drawn from this stratum, and so on. So meaning to say that stratification ensures proportionate representation in the sample of the different classes in the population. That is what is known as stratified random sampling. Whereas in the cluster sampling, simple random and stratified sampling are based on the researcher's ability to identify each element in the population. It is easy to do this if the total sampling population is small. But if the population is large, then in the case of a city, state, or country, it becomes difficult. And also it is expensive to identify each sampling unit. So in such cases, the use of cluster sampling is more appropriate. So in the cluster sampling, many times for reasons of time, economy, and conveniences, instead of drawing a sample unit as in the preceding methods, the sampling unit consists of a group or cluster of similar units. In surveying a city, for instance, there may be no up-to-date list of houses, and to prepare one would be time-consuming, laborious, and expensive. So instead of choosing 1,000 houses at random or systematically, so 20 blocks of 50 houses are chosen as the sample, meaning to say that cluster sampling should be resorted to if the other techniques cannot be done. So cluster sampling is based on the ability of the researcher to divide the sampling population into groups, so based upon visible or easily identifiable characteristics called clusters, and then to select elements within each cluster using your simple random sampling technique. So clusters can be formed on the basis of geographical proximity or a common interest that has a correlation with the main variable of the study and is in stratified sampling. Depending on the level of clustering, sometimes sampling may be done at different levels. So these levels constitute different stages. It could be single, double, or multiple of clustering. So again, you need to classify and need to select on what type of sampling you're using. So another one is a non-random probability sampling. This is one of the designs in quantitative research. The non-probability sampling is do not follow the theory of probability in the choice of elements from the sampling population. So non-probability sampling designs are used when the number of elements in the population is either unknown or cannot be individually identified. In such a situation, the selection of elements is dependent upon other considerations. So these are the five sampling under the non-probability. We have the coda sampling, number 2, accidental sampling, number 3, judgmental sampling or the purposive sampling, number 4 is the expert sampling, and last is the snowball sampling. So what does it mean in the coda sampling? So main consideration here is that directing coda sampling in the researcher's ease of access to the sample population. So meaning, in addition to convenience, you are guided by some visible characteristics such as gender or race of the study population that is of interest to you. So once the quota in the process continues until you have been able to contact the required number of respondents, meaning there's a certain quota. That's what we know as your quota sampling. And the accidental sampling is also based upon convenience in accessing the sample population, whereas quota sampling attempts to include people possessing an obvious or visible characteristics. Accidental sampling makes no such attempt. So you stop collecting data when you reach the required number of respondents you decided to have in your sample. So this is what we know as accidental sampling. Judgmental or purposive sampling is the primary consideration here is your judgment as to who can provide the best information to achieve the objectives of your study. So as a researcher, only go to those people who, in your opinion, are likely to have the required information and be willing to share it with you. That is judgmental or purposive sampling. So with a purpose and also the willingness of your respondents share information. And the expert sampling is the only difference between judgmental sampling and expert is that in the case of the former is entirely your judgment as to the ability of the respondents to contribute to the study. But in the case of expert sampling, your respondents must be known experts in the field of interest to you. So this is both the types of research, but more on in qualitative research studies. So when you use it in the qualitative research, the number of people you talk to is dependent upon the data saturation point, whereas in quantitative research, you decide on the number of experts to be contacted without considering the saturation point. In this sense, the persons with demonstrated or known expertise in the area of interest to you. That is what we know as your expert sampling. In the snowball sampling is the process of selecting sample using networks. So like for example, start with a few individuals in the group or organization, and then you need to ask for required information collected from them. And they are then asked to identify other people in the group or organization, and the people selected by them become part of the sample. So information is collected from them, and these people are asked to identify other members of the group. And in turn, those identified become the basis of the further data collection. So this is your saturation point. So it has been reached, and information also will be sought. So whereas another type is the systematic sampling or mixed design. It has been classified as mixed sampling because it has been the characteristic of both the random and non-random sampling design. In systematic sampling, frame is divided into a number of segments called intervals. Then from the first interval using the simple random sampling technique, one element is selected. So in this sense, that the selection of subsequent elements from other intervals is dependent upon the order of element selected in the first interval. If in the first interval is in the fifth element, then the fifth element of each subsequent interval will be chosen. So notice that from the first interval is a choice for the element is on random basis, and the choice of the elements from subsequent intervals is dependent upon the choice from the first. Hence, it cannot be classified as a random sample. So, in a systematic sampling, this is a method where every ninth or such every fourth or fifth member is selected from a population or n, which is arranged in some definite way to obtain a sample of units. For instance, if 10 units were to be selected from a population of 50, so 1 unit has to be selected for every 5 units. So the population is numbered 1 to 50. And the first unit is obtained at random from units 1 to 5, and every 5th unit thereafter. If, let us say, number 4 is selected, then the succeeding numbers are 9, 14, 19, and so on. So in this method, the first unit determines the whole sample. Systematic sampling is different from random sampling. So we also understand the nature of the variable, and as we all know, the variables that we have are the following: the independent variables, dependent variables, and are the confounding variables. So we also categorize the different levels of measurement or levels of data. We have the nominal, ordinal, and interval. And the number of variables really varies with the sample or population size and the sample that we need to look for. The sample size through the number of cases as to determine the sampling designs. Is it random or versus non-random? So meaning probability versus non-probability sampling. So let's proceed on statistical analysis. So there are two types. We have the descriptive statistics, and the other one is the inferential statistics, or what we know as the analytical statistics. So we will tackle first on what is descriptive statistics. So as we all know that it aims to describe the characteristics, and it can also measure central tendency, and it measures of dispersion. So descriptive statistics is used in descriptive studies as a means of describing the nature and characteristics of the event under investigation. It is also the initial step in the analysis of data in analytic research. It consists mainly of computations of indicators. So indicators, we already discussed that one, these are computed or collated collectively characteristics of the person making up the study population. So examples are the mean, variance, and frequency distribution of measurements, or the values of the variables. So we have the rates and ratios of disease occurrence, and as well as deaths. So in this method, how is the method of data analysis determined? Of course, a study will always depend on the first one is your objectives, and of course the research design. And second would be is the scale of measurement or the type of data. So in the analysis of data under the descriptive studies, it falls under the realm or what we know as the descriptive statistics. It consists mainly of estimation of indicators which are reflected to the objectives of the study. So the indicators that could be used or estimated may be limited by the scale of measurement or type of data. If the scale is nominal or ordinal, then only frequency distributions and your rates and ratios are appropriate indicators. So if the scale is interval or ratio, so it measures of central tendency and also of variation as well as frequency distribution and as well as rates and ratios can be used or computed. So I would like to emphasize on this thematic or the analysis of or consists of the following. So we have the estimation or computation of indicators in the different study groups similar to descriptive statistics, and another is to test of significance of observed difference of values of indicators in the groups, and also estimation of degree of association. So this test of significance and estimation of association will be under the inferential statistics. So let's try to figure out on the diagram for data analysis. So we have here from your objective under the descriptive statistics. So this is to describe events or identify the risk factors and also its causes. So you have your independent, dependent, and confounding. It's your partly under your objectives. And you have your research design. So you will use your descriptive or your cross-sectional. And the type of analysis you're using is descriptive statistics. So in the scale of measurement, so the 4 levels of scale so utilized here. So under the descriptive statistics, we have the nominal or ordinal. You're using with this and the analysis of indicators under the nominal and ordinal. So you will use computation of proportions like the rates, the ratios, frequency distribution. So whereas the scale of measurement under the interval or ratio, so you will have the computation of proportions plus the mean and variance. So how are some of the computations actually performed? So for the computation of the indicators, we have 5. So let's try to check if 5. So I think it's 4 only. So we have here the first one is the first indicator is the mean. So we are familiar with this one, mean, median, mode, the standard deviation. So in the mean, so we have the mean in the summation, observed values, and then the total number of observations. So you have the mean equals to the summation of observed values divided by the total number of observations. So the second one is measures of variation, meaning with the use of 1, 2, 3. So we have the standard deviation, the standard error, and the standard error of the difference. So under the standard deviation, so you have the specific formula for standard deviation. And then standard error also, you have the specific formula. And also standard error of the difference in the formula. Another is the range of normal values and percent distribution with categories and according to numbers. There is specific numbering per percentile. So where A1, B, and C are the number of observations falling within the respective categories, and N is the total number of observations. The frequency of occurrence of an event is related to the total possible occurrence, and absolute count is usually meaningless unless there is set into a proportion. So another one is the comparison of absolute numbers is generally not possible because of the difference in the sizes of population or sample. So when the numerator is part of the denominator, the proportion is arrayed. If it is not, then the proportion is erasure. The examples of this are the following. We have the case fatal rate. So as we all know, the formula for this is the case fatality rate, wherein is equal to the number of deaths over the number of cases times 100. The second example is the fatal death rate or ratio. Fatal death ratio is equal to the number of fatal deaths divided by the number of live births times 1,000. And the last one is the incidence rate. So wherein it's equal to the number of new cases over a period of time divided by the population at risk times 100,000. Alright, and then for the ratios and rates, so there's a specific formula for ENP as the proportion of sample with attribute to the study. Another one is the P, proportion of population with attribute. Q is 1 minus P, and then N is the number of sampled subjects. So comparison between two means and proportions or two sample cases, you have the mean, the rates and ratios. So for the mean, you have the summation mean of group 1 and then x squared mean of group 2, then SP for full variance, and N1 and 2, these are the number of subjects for group 1 and group 2 respectively. For the rates and ratios, formula also, so where P1 and P2, these are proportions of subjects with attributes from group 1 and group 2 respectively, and P for the proportion of subjects attribute in two groups, and Q is equal to 1 minus P. N1 and N2, these are number of subjects in group 1 and group 2 respectively. So this is under your descriptive statistics. To elaborate further, so I will upload more videos about descriptive statistics and inferential statistics, and also other method on how to compute on respective statistical numerical data. Now, another part of the statistical analysis is your inferential statistics. So in inferential statistics is the method of analysis used in analytic studies. It consists of computation and comparison of indicators and tests for significance of observed differences and determination of degree of association. So correlation and regression analysis is also a component of your inferential statistics, or what's known as your analytic studies or statistics. So in this sense, the parameters are your population measure, statistic sample measure, and we will also discuss what does it mean of univariate, bivariate, and multivariate. So we all know that the method of data analysis is determined again on the objectives, on the research design, the scale of measurement, or the type of data. So in the analytical studies, so analytic studies are used with your inferential statistics for the analysis of your results. So the primary aim of the analysis is to determine if the statistical association between the independent and dependent variables can be established, and it also determines the degree of association. So as we all know, the analysis consists of number one, estimation or computation of indicators in the different study groups, similar to descriptive statistics, and also to test of significance of observed or difference of values indicators in the groups, and the third is the estimation of degree of association. So as we all know, in this schematic for data analysis, so in the objective, so for inferential statistics, we observe that in the objectives, this is the test, hypothesis, or your intervention. In the research design for inferential statistics, you will use analytic. And the type of analysis is what we know as your inferential statistics. So for the scale of measurement, so the four levels of data, so we have nominal, ordinal, interval, and ratio. So under the inferential statistics, the nominal and ordinal for the analysis indicators, so you will have the computation and comparison of proportions, plus the test of significance, plus the degree of association if you're using nominal and ordinal in a scale of measurement. Whereas in the interval and ratio, the levels of data. The analysis of indicators are computation and comparisons of proportions, plus the mean and variance, plus the test of significance, and the degree of correlation. So some indicators are already discussed a while ago about the mean and the variance. So again, computation of indicators, we have the mean, where it's mean, and we have the summation and the observed values and the total number of observations. Also, the test of significance. This is appropriate statistical test for the determination of significance. Depends on the type of problem and scale of measurement. So the recommended tests based on the measurement are presented. So the methods of computation are found in standard response statistics. So I have here examples of comparison of indicators and test significance. So in this comparison with the universe for one sample case, so you have the mean, so meaning the sample mean, and you have the population mean. You have the standard deviation of the sample and the number of subjects, and there is a formula for that. So as we compare on statistical test to determine statistical significance, now we have the type of problem, we have the interval and ratio, and the scale of measurement, and we have ordinal and nominal. So under the type of problem, so comparison of parameters or indicators. So if you have a single population, the scale of measurement under interval and ratio, we will be using a z-test or t-test. For the scale of measurement under the ordinal is you'll be using a Kolmogorov or Smirnov one sample test. So under the nominal is the chi-square test. So another problem is if you have here or the comparison of parameters or indicators with two populations. So for related samples, interval and ratio, you will have a paired t-test. And then for the scale of measurement under ordinal, you will use Wilcoxon match pairs or design rank test. For the nominal is Mach-Lemmers. Another two populations with the independent samples. So under the interval and ratio, you will have independent t-test, and the scale measurement under ordinal, you have the Mann-Whitney u-test, and for the nominal, you have the Fisher's abstract probability test, and you can also use the chi-square test. And another parameters, you have three or more groups. Related samples under the interval ratio, you have the f-test or two-way analysis of variance. That's ANOVA. And then you have the scale of measurement, the ordinal, you have the Ritzmann's two-way analysis of variance. And the nominal is Cochrane's Q-test. And then in the independent, you have the f-test or one-way analysis of variance. Ratio. For the ordinal, you have Wallace, the one-way ANOVA, and then for the nominal, you have the chi-square test. Study of relationship between variables and in the interval and ratio scale of measurements, so you will use regression, correlation, and then for the ordinal scale of measurement, you have the Spearman rank or correlation of coefficient, and then for the nominal, you will have kappa test or tendency coefficient. So I already discussed this one earlier. Now on the measures of degree of association under the cohort study, then you have two: relative risk and attributable risk. There is a specific formula for that. Under the case control study, you have that the odds ratio, cross product ratio. And then for the experimental and intervention study, so you will have the protective value, then correlation and regression analysis. So you will already identify under the linear relationship as well as the non-linear relationship. So in this sense, you how are the results of the test or the study interpreted? So in the analysis and interpretation, these are facilitated when statistical data are presented in clear and concise form. So as a step in analysis and interpretation, data are presented either in tabular or in a graphical forms to enable the researcher to examine the findings well. So we will talk about tabular presentation. So the first one here is numerical findings of the study are presented in a compact and orderly manner. So they are placed in cells or compartments which are systematically arranged in contiguous rows and columns. So the exact numerical values are in this illustration. The parts of the table are illustrated like this. You have the title, you have the column, you have also the column heading, the compartment or cell, row, the tab, you have the body table, you have the marginal totals, below at the bottom part you have the total and the marginal totals. And don't forget if there's any footnotes, you can indicate that one. So for the stub, this indicates that the basis of classification of rows or horizontal series of figures. For column headings, this indicates the basis of classification of the columns or vertical series of figures. And for the body of title, it's made up of the figures filling the cells or compartments. And for the title, this indicates clearly, briefly, and comprehensively what the figures in the body of the table stand for, how the data are classified, where and when they are obtained or they were obtained, and then placed above the body of the table. So another part is aside from your tabular, then you also have the graphical presentation. So graph allows the researcher to have an overall view of the statistical data. So the detailed information is not shown, but then the trend or relative frequencies can readily be appreciated and or recognized in either by graph or in the use of your diagrams. So the relative values can be seen and estimated from the vertical scale or sometimes as your horizontal scale. So there are various types of graphs. So you can check that one, or I will upload in your LMS an example of different types of graphs and also sample of graphical presentation. So interpretation of the results of the study should always be done in the context of the objectives. Again, it will always go back to your research objectives. So from consistency from your research objectives until how you will do the statistical analysis and process. So, and also in your data collection, you always refer back to your research objectives. That's why it's very important to have the right variables that you need to also to indicate, and also in the context of your creation of your objectives. So interpreting the analyzed data and determining whether the findings support the hypothesis or not. So it is answering the research questions. So the objective of a descriptive study is to determine the nature and characteristics of certain events. Interpretation of the results, therefore, is the development of the description from the analyzed data. So the description is quantitative in terms of the computed indicators. So interpreting the results of the study is not merely stating the findings in complete sentences and presenting them in a textual forms. So a cross-sectional study is undertaking to generate hypothesis or relationship between a factor or exposure and an effect or outcome. So a hypothesis can be generated if the results show a greater prevalence of outcome among the exposed than among the unexposed. So an analytic study tests the hypothesis of relationship. So the statistical analysis determines if the statistical association between exposure and outcome exists. So a statistical association is established if a statistical significant difference in the indicators is found between the groups being compared, or a high correlation coefficient is obtained in a study of relationship between quantitative variables. So statistics only show statistical association. They do not prove cause and effect relationship. So in addition, the statistical association is said to exist if significant odds ratio or relative risk or effectiveness value is found in the appropriate study. So statistical significance and practical and clinical significance should not be confused. So this refers to the benefits that may be derived from the application of the knowledge or technology tested by the study. So statistical significance measures the probability of accepting a wrong hypothesis or rejecting a true hypothesis. So in statistical significant finding does not necessarily mean that the knowledge or technology is beneficial. So a statistical significant finding or observed difference is one that is not likely to have occurred by chance alone. So there is a cause responsible for its occurrence other than chance. So whereas chance, this refers to random error of sampling. So the value of an indicator derived from a sample is expected to deviate or vary from the true value just because the entire population is not examined or observed. This is what we know as your sampling error. So a significant finding implies that it is not the consequence of sampling variation. So it is conventional to place the probability of occurrence by chance at more than 5%, and anything less than 5% is improbable unless there is a cause responsible for it. So when a difference has a probability of occurrence of less than 5%, it is said to be statistically significant at 95% confidence level. In short, when the findings are statistically significant, it means that they support a hypothesis of relationship. So what does a statistical association imply? So it is true that a finding of a statistical association supports a hypothesis of relationship, but it does not mean absolute proof or proof beyond doubt that there is a cause-effect relationship. So statistical association does not imply causal relationship only. So here, its statistical association may be a cause association, it could be direct association, or spurious association. So if you talk about causal association, this means that the factor is essential for the outcome to occur. Just like, for example, an infectious disease agent. Another, the presence of the factor increases the probability of the outcome to occur. Example, predisposing factor, or one of several disease agents of a disease. That is what we know. Because of that cause, there's a reason or a cause. So whereas indirect association, this means that the factor is causally related to the outcome through an intermediate variable. And whereas the spurious association, this results from biases in the study, just like your selection biases and intuitive. So these are all your inferential statistics. I hope that you learned something. But when talk about univariate before we end, so univariate is also known as your frequency table. So just remember, univariate are your frequency tables containing information about one variable. That's why it's unique the word one, univariate. So one variable. In the bivariate, this is also known as your cross tabulations, meaning containing information about two variables. In the multivariate or the polyvariate, this contains information about more than two variables. So again, in the univariate frequency distribution, these are grouped respondents into the subcategories into which a variable can be divided. Unless you are not planning to use answers to some of the questions, then you should have a frequency distribution for all of the variables. Whereas in cross tabulations, this analyzes two variables, usually independent, dependent, or attribute or dependent, to determine if there is a relationship exists between them. So usually the absolute number of respondents and the rows and the columns of persons who still examined. So under the cross tabulations. So again, univariate, also known as your tables, and then bivariate, also known as your cross tabulations, and multivariate, or what we know as your polyvariate. So these are information on more than two variables, multivariate. Okay, so these are all your data processing and data analysis. So I hope you learned something, and then please expect an examination. So kindly open your LMS, and then you open the post-test examination. So you have 3 examinations. So after this module, so, and also I will give you another task. So the continuation. So I would like you to make a code book or coding sample of your questionnaire from what you have done in your first task, and this is now the continuation of your task number 2. So I will post it one in your element. So thank you so much for your time, and have a great day. Bye bye.